Hello everyone, welcome to In 5 Minutes. In this video, we are going to see the problem on how to make an equation exact. First, we will find the partial derivative of n with respect to y and partial derivative of n with respect to x, and we will check whether these two are equal. In this case, it will not be equal, so our equation is not exact. Then we will represent our given equation in some form. So in this, it is a type 2a form, so it will be of the form f1 x comma y into y dx plus f2 x comma y into x dy equal to 0. So after representing our equation in this form, we will find what is integrating factor. After finding integrating factor, we multiply integrating factor by our given equation. So after multiplying integrating factor with a given equation, we are again going to find the new m1 and new n1, and again we are going to follow this procedure. This is how we are going to solve this problem in nutshell. So to start with, this is our question, solve this. So first we will find what is m and what is n. So as you can see, this equation is of the form m dx plus n dy equal to 0. Is m is nothing but y and n is nothing but x into 1 minus 3x square y square. So I am just going to simplify this equation, so it will be equal to x minus 3x cube y square. So after this, we are going to find the partial derivative of n with respect to y, and x is constant. So derivative of y is nothing but 1. Similarly, we are going to find the partial derivative of n with respect to x, and here y is constant. So the derivative of x is 1 minus y square is constant. What is derivative of x cube? Derivative of x cube is 3x square. So as you compare these two equations, partial derivative of m and partial derivative of n, so we conclude that partial derivative of m with respect to y is not equal to partial derivative of n with respect to x. So this equation is not exact. So this equation is not exact, but as you can see, this equation is of the form f1 x comma y into y dx plus f2 x comma y into x dy equal to 0. So here we have only y term and dx. We do not have f1 x comma y. So in this, f1 x comma y is nothing but equal to 1. So this part is similar to this part. And here we have equation x. So here we have x. Here we have dy. Here also we have dy. What is f2 x comma y? So f2 x comma y is a function having x and y terms. So this is of the form f of x comma y. This can be represented as f of x comma y. So this is f2. So as you can see, this equation is in this form. So for this form, the integrating factor is given by 1 upon m into x minus n into y. So we are going to find the integrating factor. So the integrating factor is 1 upon mx minus ny. So 1 upon what is m? So m is y and this x here minus what is n? N is x minus 3x cube y square into this y. So if we solve this, we will get xy. This minus sign will go inside, then we will get minus x, and this y will also get multiplied to each of the term. So we get x into y, and minus will become plus. So and this y will be multiplied by this y square, so it will be 3x cube y cube. So we can cancel this xy plus xy and minus xy. Then we will get integrating factor as 1 upon 3x cube into y cube. So this is our integrating factor. So in integrating factor, we can neglect the constant terms. Like we can neglect this 3 is constant. Like if we multiply by this 3, it will not create any issue. What is our given equation? Our given equation was y dx plus x into 1 minus 3x square y square dy equal to 0. Now we are going to multiply this equation by integrating factor. So integrating factor is 3x cube into this equation. So now we are going to multiply this with each term. So if we multiply by this, here we will have 3x cube into y cube, and here also we will have 3x cube into y cube. So as you can see, this 3 can be taken outside, and when it goes here, so it will be multiplied by 0. That means we can neglect the constant terms in our integrating factor. This y and this y will get cancelled, so it will become y square. So this is our equation. So this y and this y will become y square. This x and this x square will get cancelled and it will become x square. This x cube and x cube will get cancelled. This y square and this y will get cancelled and we will get this equation, which is 1 upon x cube y square dx, plus here we have 1 upon y cube into x square minus 3 upon y into dy equal to 0. So this is now our new equation. So this will be our m1 and this will be our n1.